our previous tutorial, we designed this perpetual machine. So if you already design it, you can do the next part. If you did not design it, please watch the video and design it. And if I go to the right side view like that, you have to make sure that for this consider this when the ball is rolling here, it's going like that. So this shape is important. So make sure it's making a circle like that, this shape, like a arc portion, and the rest of the circle is going like that. It will direct the ball into this base. So make sure for that. Okay. So if you already design it, it's good. If you did not, just watch the tutorial and design this perpetual machine. So we have the ball here. We have to make sure this hole is bigger than this ball. So this ball must pass this component. And here this one, these wire types, they are not in the correct position. So they are not like stopping the ball because we are going to use the rigid body in the blender. So it's stopping if this wire is here in this hole, it's touching the ball, it will stop the ball in this hole. So make sure for that. Okay, in the previous tutorial, we also applied image texture and the environment texture. So the setup is ready to run according to the previous tutorial. So everything is defined, the designing is done. We just need to use the rigid body simulation. Okay, so we have the ball here in this hole. First, we are going to change its location. So it's falling and then rolling on this base and then going to move on this wires on this defined path. So select this ball, press 3 on your numpad so you can see it in the right view. I am going to press G and log it in the Z direction to move it in Z, and I am going to move it here. Then we have this property window, just change its Y location like that. So it's not just directly falling on this hole. Okay. So next we are going to use the rigid body physics for this ball. So as you know about the rigid body physics, if you open the properties of the rigid body physics in the Blender manual, you can read about the rigid body physics and what it do. The rigid body simulation can be used to simulate the motion of the solid objects. It affects the position and orientation of the object and does not deform them. And all the other properties and the tools which are used in the rigid body properties are here. You can study it and get the theory about the rigid body simulation in the Blender. So this is good. You just go there and read it one time so you know about the theoretical background of the rigid body simulation in the Blender. So we have different types of the role of the rigid body in the simulation. We have the active body, the object in the dynamic, and it's directly controlled by the simulation result. Passive, the object remains the static and is directly controlled by the animation system, thus does not have any dynamic properties. Okay, so first this ball we want this ball to have the rigid body properties. So go here on the physics properties and add the rigid body physics for this ball. So when we click this property window will be appear here. So we have the different properties here. You can go here and read about them so you know the theory. So the first one is active. Like you want to make this ball an active rigid body, so when you run this simulation it will fall. So this is the active. So if we want a body like this one, we want this uh, component to have the rigid body physics, so click on it, but we don't want to have it active. We want active mean it will move. So like this we define it the active. Now if I click the play animation, you see this is falling because this is also selected the active. So now this ball is active, and this component we are going to make it passive. So when I run this animation, you see the ball will fall on this component. Okay, so I'm going to select this ball, and under the setting we have the mass, we have this dynamic and the animation. options, and under that we have the collision. So for this dynamic option, if I check it, it will the rigid body physics will act it. But if I uncheck it, the rigid body physics will not act on this ball. And this animate, if we want to define some position and want to animate this ball, then we check this, and it will then perform the animation according to the location and the scale. So these are the things. Okay, now for the collision, we have the shape and the source. So for the shapes, uh, we selected this ball or rigid body physics. So for the shape, it will define the shape in the way the body is reacting with the reacting mean having the collision with the other body. So this shape, it matter. So convex hull, it is a simple shape for this ball, and we have different uh, collision shapes. So for the shape, it's mean the body is going to uh, collide with the other body, and according to the defined shape which we define here. So for the convex hull, it is a simple, but for our requirement, we basically needed the shape of the sphere, because this object, its mesh is like a sphere. So we select the sphere, it will make the simulation easy. We can also select the mesh, the uh, or the sphere. The sphere will be good. Okay, we select the sphere for this ball. And for the surface response, there is friction and bounciness. For the friction, you can decrease it. The value 0 mean we have a zero friction, there is no friction. And for the 1, we have the high friction. And we have the other option here. So just select this one. For this shape, the convex hull is a simplest shape. But for this, we are going to define the mesh. So for the mesh, this object, and the collision between them will be according to the same shape we have for this component. So that means the mesh is good. Okay, and now select this one, and we are going to apply the rigid body physics, and this component we also want it static, not moving. Select it static, and for the shape we are going to select it the mesh. Okay, so you can also read about the other properties of the rigid body physics. Go here and expand it, the manual, and you can read it for the like for the setting. You can click here and here dynamic, the enable disable rigid body simulation for the object animation. If we go to next, collision, it's defined about the shape, determine the collision shape of the object. These can be broken into two categories: primitive shapes and mesh based shapes. Box cylinder, you can read about the properties of the rigid body physics, and it will really help you to understand these options. Like see the surface response, friction resistance of the object to movement. So bounciness, the ball will bounce from the surface. So these are the properties. Just read about it. For this simulation, we only needed these options. So we make it the shape, and the mass, we are not going to change it. And for this one, we are going to make it passive and mesh. And for this one, we are going to make it passive and mesh. Okay. Now I am going to expand it. If we run this simulation, you can see it's going like that. Ball move here and stop at this position. Because for the perpetual motion, basically it does not exist. In the perpetual machine, which you see, basically they use a motor at this place, so it will power this ball to give a power, so this ball will move here and make a rotation. Or they use the magnetic in this surface. It does not really exist, this perpetual motion. But to simulate it in the blender, we are going to uh, add an external force which will power this ball, so it can complete a rotation and move it in its initial position on this surface. So we needed to define an external power. Okay, so this is the motion which we're getting here. Ball just stop and fell and just stop here. So to add the force, external force, we are going to go to the add menu, and we are going to select force field. We have different types of the external force. What we want for this application, we are going to use the force field. So, and then we have to change the location of this force field. So for this one, I tested this force field at different locations. So just select this force field and G to move it and place it here at this position. Or you can test it by changing the position and see the reaction of this force. So select this and then go to the physics properties, and under the properties of this force, we have the type of force, different types of the forces, but for this one we needed the force. For the shape, we have the pointy shape, the line, plane. You can also read the its theory here in the Blender manual. Okay. And here we have the strength, like how much force is applying on this object. And then if we go to the follow, because we want this force to act it when this is like at this place, and it's react in the negative z direction. So for the follow, we are going to select the shape sphere, and z direction we are going to make it minus z direction. So the force will act in the minus z direction, and it will get with power like that. Okay. Okay, next. Uh, we are going to increase the strength of this one. Before the ball is stopping at this position, so now we are going to make it 500, and let's see its reaction. So now you can see the force field, we apply it and its direction is both z. We needed to change it to minus z direction. So now the ball is going, and now you can see before the ball was stopping here, but now it's moved here. So when the ball is coming back, the force is also applying, giving it little bit power. So the strength of this force, we have to make it little bit higher. Then G, then see its reaction. Now the ball is coming at this position. So I am going to press 3 on numpad and just select this force field. S to scale it little bit, and then G to move it and place it at this position. So test the location of this force. So it must give the enough power to make a complete rotation. Now let's just see, the ball is falling and it's coming here. I am going to change it to, now try to find how much power it's getting. Okay, here for the seeds I am going to make it 20. Okay, so this location, we have the location good. It's making rotation, but a little bit more, 400, 4000. Okay, that's perfect. A little bit more. So basically, it's completing a circle, complete circle. So the ball is going down and then and again like that. So we achieve this motion, and now we just needed to use the timeline to make the setting so we can make a loop of this animation. So you can see the ball is falling here and at this position, frame 50, 51, 52, 53. So to make this loop, we have now 50, the frame of 54 where we cannot see this ball. So if I go here, the ball is here at this position. What is 53 on 53? So basically at this location, we can see the ball is going downward on 50 frame 53, and then it's going, going at 120 frame. So basically we make the this loop, and then we render it, and add it in the sequence. Okay, so go here to the render properties and make it cycle. And here we have this. And under the sampling, for the render sampling, I am going to make it 30. The output properties, I am going to select a location where you want to make this render go. And for the file format, we are going to select the PNG because we are going to make the loop of this animation. And if you go here on the scan properties, go to the scan properties and under the rigid body, world expanded and under the cache expanded. And for the simulation, basically we want it from 53 frame and end it on 120 frame. Make sure you selected that. For the go to this scan properties, scene properties, and go to the rigid body world. And here you under the cache, make sure simulation for from 53 frame to 120 frame because we want this simulation to start from 53 and end it on 120 because we are going to make a loop of this simulation. And also you can make it here from the start 53 and for the end we are going to select 120. So you can see here we have this change the rent cycle to EV. We can easily absorb it, make it EV like that. And here you can see the ball is moving down and we have this loop. It's not 120. The frame selection is wrong. Okay, go to the scene properties. We make a mistake, make it 250 and select bake it. And now you see the 173, 172. Okay, so make here delete bake and under the end we are going to select 172. So for this simulation we want the render engine to render it from the 53 frame to 170 frame. Okay, and select the cycle. Same way you can also see frame start 53 and end on 172. So you have to basically find the location of this loop and then just go here under the render and render animation. So click it, it will make the sequence of the simulation in the form of the images. Like here we see 50 in the images. Our the output will be the images. Now we use these images to make the simulation. So you just go here and when you render it, the you have all the images. Then just go here and click new and under the video editing click on it, or you can also expand it here and click the video editing and rendering video editing. So here you are going to add the click add and add a image sequence. You are going to add the image sequence. So here I have these images like that. This is a render. So select first images, then move downward and shift and select the last image and add images. Now you just move it here. So we want it from frame 1. Okay. Okay, now you can see we you added all the images and now you get this loop of the animation. Then select this one and shift D and place it like that. Then again shift D, select this one, place it, shift D, place it. and here try to find 221 to 11. So now you have the this loop of the animation. So just make sure you render the simulation in the form of the images, then go to video editing and add the image sequence and add all the images here. So it will make the loop of the animation, and then just go here and render it again in the form of the video. So select PNG, select FFMEPEG video. Select this one and then render it, render animation, and it will make the video of this loop of the animation. So thank you so much for watching this tutorial, and if you really like my tutorial, please subscribe my channel.